So let's find some second derivatives, and in fact, I even want to carry it one further, of kind of some polynomial and other basic functions that we've worked with. So let's consider the function f of x equal to 2x to the fifth plus the cosine of x and plus the natural log of x. And we'll find the second derivative, but really we can find any derivative here. So let's go ahead and find the third derivative of f. So I'm just going to take the derivative once. F prime of x is equal to, well, 2x to the fifth, that's 10x to the fourth. The derivative of cosine of x is minus sine of x. And the derivative of natural log of x, we know, is plus 1 over x. So now I want to take the derivative of this function. Well, I know when I take the derivative of 1 over x, it's to my benefit. We learned in the power rule that I want to write that as x to the minus 1. So let's rewrite this as 10x to the fourth minus the sine of x plus x to the minus 1. Now I've got it in a form where I can pretty easily take the second derivative. So f double prime of x, well, the derivative of this is 40x cubed. The derivative of negative sine of x is minus cosine of x. And I know with the power rule I can bring the minus 1 in front of x and decrease the power down to minus 2. So if you take a look at some of the patterns that are happening here. Whenever I am taking multiple derivatives, x to a power just keeps reducing in power. In fact, eventually this would zero out, this little piece right here. Sines and cosines are going to alternate, except they're going to differ by a negative. Whenever we took the derivative of cosine, we got negative sine. But the derivative of negative sine was not, we did not get a sign change there because the derivative of sine is cosine. And then when I did natural log of x, the first thing I got was 1 over x. But now I'm going to get a repeating pattern here where the power of x is going to keep decreasing. And because I'm dealing with negative exponents, I'm going to get a sign change here. So one of the things I want to focus on whenever I take this third derivative, obviously 40x cubed is going to be 120x squared. The derivative of negative cosine, that's going to make it a sign change. That's going to now be plus the sine of x. Now then, over here at minus x to the minus 2, you'll notice that I didn't rewrite that taking care of the negative exponent. That's because it's already set up for you to take the derivative again. So I bring the negative 2 in front, it becomes plus 2x to the minus 3. And now because I was trying to find the third derivative, I'm going to go ahead now and take care of my negative exponent and say that is 120x squared plus the sine of x plus 2 over x cubed. And there's my third derivative. And you can see it would have been really easy for us to take a fourth derivative, fifth derivative. We could have kept going through this process. So when we talk about taking higher order derivatives, it is the same process that we've already learned, just the fact that we can do it and how we express it with its notation.